Hi everyone, this is the third part of the video lesson for 4.2, critical points, local maxima, and local minima. Again, if you haven't watched the first part or the second part, please go back and watch them first before continuing in part 3. Now in part 3, we're looking at example number 3 on page 179, question number 13. So, let's try this. Again, it is a thinking question. If you want to read it, press pause. Try this for 5 minutes first. I'll be right here. And when you press play, I will continue. Here we go. Number 13. Find the values of a, b, c, and d such that g of x equal to ax cubed plus bx squared plus cx plus d has a local maximum at 2, 4 and a local minimum at 0, 0. Step number 1. You can divide this into 2 different columns, and we're going to be doing this choice because we have 2 critical points, 2, 4 and 0, 0. So the first step is, notice how this point 2, 4 is part of this equation g of x. So I'm going to plug in y to be 4 and x to be 2. Now 4 equals to a times 2 cubed plus b times 2 squared plus c times 2 plus d. Now, because you've tried it for 5 minutes, I am going to go slightly faster. So 4 equals to 8a plus 4b plus 2c plus d. Now likewise, if you look at this in the second column, I'm going to plug in x and y to be 0 and 0 respectively. Again, here comes the mental math. 0 equals to d. Are you still connected? When this is 0, they all disappear and you're left with d. Now, we found d, which means you can plug it back to here, or you can just plug it back into there. This means this term is going to be 0, and you can divide both sides by 2. And when you do this, 2 equals to 4a plus 2b plus c. And I'm going to put a box around this. I'm going to come back to it in a moment. Now, we're going to repeat this process again in a moment with the derivative. And the reason why we're doing this is because there are 2 critical points located at 2 and 0, and to use them, first you have to find g prime. So g prime equals to 3ax squared plus 2bx plus c. So again, in the first column, you set this to be 0. The first x value is going to be 2. So I'm going to plug in x to be 2. Again, I'm assuming you spent at least 5 minutes trying it on your own. I'm going slightly faster. 3a times 2, that's going to be 12a. Plus 2b times 2, that's going to be 4b plus c. In the second column, when you plug in x to be 0, this entire term just becomes c. Again, you can plug this back into here, and because c is going to be 0, you can also divide both sides by 4, which means 3a plus b equals to 0. And likewise, you can also plug in c back into here. This implies you can divide everything by 2, which I'm going to write underneath. So 1 equals to 2a plus b. Now, you have 2 equations of 2 unknowns. So from grade 10 academic math, you've done this. If I want to eliminate b, I can subtract. And when you do this, 0 minus 1 is going to give you negative 1. 3a minus 2a is going to give you a. Now, you can plug it back to this one, or you can plug it back to this one. It's really up to you. But b, when you work it out, it's going to be 3. So this means, therefore, a equals to negative 1, b equals to 3, c equals to 0, d also equals to 0, or if you want to express the function g of x and you plug it back in, that equals to negative x cubed plus 3x squared. Okay? Again, here's some check marks. There you go. One more example. So, if I go back to the page 4, the last example, this is a little bit beyond thinking, but it's good for you. Number 15 on page 180. Now again, this is probably the hardest example we're doing today. So again, press pause, spend 5 minutes, 10 minutes if you like. Just try this. And when you press play again, I'll be right here. So again, this is page 180. Okay. Number 15, consider the function f of x, 3x to the 4 plus ax cubed plus bx squared plus cx plus d. In part A, they're asking you to find constants a, b, c, and d such that the graph of f will have a horizontal tangent at -2, -73, and 0, -9. Now, again, we've talked about this. Horizontal tangent just means the specific slope is going to be 0. So, before we move on to the horizontal tangent part, the fact that you're given 2 points, -2, -73, and 0, -9, this means you can plug it in. So just like the previous example, I'm going to set it up in 2 different columns. In the first column, I'm going to plug in y to be -73. I'm going to plug in x to be -2. Now, I'm assuming you've tried this. I'm going fast. This is a test. You have to be in the moment. When you plug in x to be -2, this would give you 48 minus 8a plus 4b minus 2c plus d. Now likewise in the second case, if you plug in y to be -9 and x becomes 0, you should be able to see that d is the only term that is left. And of course, you can plug this back into the first column, and when you rewrite this, you can bring the 48 to the left. That's going to be -112, which equals to -8 times a plus 4b minus 2c. And if you divide everything by 2, that's going to give you -56 equal to -4a plus 2b minus c. I'm going to put a box around this. I'm going to come back to this in a moment. So again, I am going to divide this column, or divide this into 2 columns. Right after, we find the derivative. So f prime equals to 12 x cubed plus 3a x squared plus 2bx plus c. So we know the 2 critical points. And this happens when you set f prime to be 0. In the first case, the critical point is going to be -2. When you plug it in, this will give you -96 plus 12a minus 4b plus c. Likewise, if you look at the second column, the second critical point is going to be 0. And at this point, I really hope you're in the moment. You can see that c becomes 0. When you plug it back into the first column, that becomes 0. You can also divide everything by 4. I can also bring -96 to the left. That becomes 24 equal to 3a minus b. Now, just like the previous example, right? You can also plug this back into the first box. That becomes 0, which you can now copy underneath as I'm dividing everything by 2. So this is -28, which equals to -2a plus b. Again, my goal is to find a and b. I'm going to add this time 24 minus 28, or 24 plus -28 is -4. 3a plus -2a is going to be a. So a is going to be -4. And again, you can plug it back to this one. You can plug it back to this one. When you solve for b, b equals to -36. So all this means is you've found a, b, c, and d. And you can write down at this moment, if you plug it all back in, f of x equals to 3x to the 4 minus 4x cubed minus 36x squared minus 9. So that is part A. In the second part, it says there is a third point that has a horizontal tangent. Find this point. No problem. This is how you do it. In part B, again, this time when you find a derivative, you have the exact numbers. And this will give you 12x cubed minus 12x squared minus 72x. Now, there are 3 points. You found 2 of them. And the reason why I can go a little bit faster here is because you would have 2 to 3 answers, which we're going to verify in a moment. First of all, there's a common factor of 12x. In the brackets, it's going to be x squared minus x minus 6. If you go through simple factoring, this would give you x minus 3, x plus 2. And as you can see, there are 2 answers that we found or that was given to us from the beginning. So when you set this to be 0 and you solve for x, 2 answers were given to us. And the new answer is going to be x equal to 3 because 0 and negative 2 was given to us. And the new answer, the one that we're looking for, is x equal to 3. So that is the new x value. And of course, always form the habit to find the point, not just the x value. So therefore, the third point equals to, and again, once you plug 3 back into the original, in case you're not sure where the original is, this is the original, you plug it back to here, and you can take the calculator. When you work it out, the point is going to be 3, negative 198. So that's how you do part B. In part C, it says, for all 3 points, determine whether each corresponds to a local maximum, a local minimum, or neither. So again, this goes back to MHF. I hope you remember that. When you think about f prime, which is 12x times x minus 3 times x plus 2, you want to make sure you can find out when this is positive, also negative, of course, and you can draw this number line. And when you draw this number line, you will discover, again, there are 3 anchor points located at negative 2, 0, and 3. From MHF, you can tell by inspection, this is going to be positive, odd. And you can tell that it's going to go from quadrant number 3 to quadrant number 1. The exponents are odd, which means you can cut just like that. So based on this, again, think about everything we did from the beginning today. The function is decreasing, increasing, decreasing, and increasing. So the fact that it goes from decreasing to increasing, this is the minimum, which is located at negative 2, negative 73. This is the maximum because it's increasing then decreasing, located at 0, negative 9. And of course, it's decreasing, increasing. So this point is going to be the minimum, which we just found. The third point, 3, negative 198. So here's a bonus idea I'm going to offer you. And if you graph this, again, you can verify this with Desmos, which I did with the other example. But if you do this kind of manually, very quickly, the function looks roughly something like this, right? It's going to go down, then go back up, and go back up again. And of course, the corresponding critical points is going to be somewhere here. So 3, negative 198. I know it's not drawn to scale. 0, negative 9. And of course, the first point, negative 2, negative 73. And that's going to be the function f of x. Now, really important, one last thing. Please do your homework. Your math skills can only be as good as the last set of homework. So try this, and until next time, all the best, and I hope this makes sense.